The experiment I'm going to be undergoing today is Franklin's bell. Benjamin Franklin, a very important person in history, for he's one of the founding fathers for the United States of America, a novelist, scientist, and much more. I would go more in depth with him, but he's just an incredible person, and it would take too much time. And primarily, I'm just going to work on his creation, which is the Franklin's bell. So how would this work? Franklin's bell would ring only if there's a storm cloud in the air or if a thunderstorm is on its way. And how he would do this is he knew that the clouds were negatively charged, right? And then the earth would be positively charged. So through a lightning rod, which is his creation, he would allow a passageway from the clouds through the lightning rod through a system which I'm going to be explaining right now. Alright, so here is an old TV. Alright, for this experiment, we'll be only using, you can only use an old TV because it produces a static electricity on the surface of its screen. So no LED TV, 4K resolution TV, only an old TV that creates static electricity on the surface of it. Alright, so now we're going to be using electrons to be passed through the TV to the aluminum foil. Alright, the aluminum foil is then going to pass the electrons through to the alligator clips and then to the first Coke can. Alright, the Coke can will now be negatively charged, and there's going to be an insulator right at the top, which is the pencil, and it's going to be hanging from just a piece of string and a pendulum, which is acting as the Coke can tab. And then there's a second Coke can that's going to be neutrally grounded by me right here, by the other end of the alligator clip. Alright, so as we know that the first Coke can is negatively charged, and one of the laws is that some neutral objects are attracted to charged objects. Alright, so that's what we see right there. It's being attracted right there, but as soon as I ground this experiment, we should be able to see that the pendulum will move back here because it's being repelled. Light charges do repel as soon as it touches it. This pendulum will then become negatively charged. Alright, and then two light charges repel, and that kinetic force that's produced from the repulsion is now going to be touching the second Coke can, and then the pendulum will now become neutrally charged. Alright, and as soon as it touches the second Coke can, the surplus amount of electrons is then going to be passed through me, because I'm grounding it, and then the pendulum is now going to be neutral again. And then we expect to see it going back and forth as the actions the transfer of electrons are being repeated. Okay, so let's see it in motion right now. Alright, so I'm going to turn on the TV and see what happens. Alright, there we go. See the constant flow of electrons being passed through back and forth. Alright, so there, my friends, is Franklin's bell. And thank you for watching.